Our last video of the week is about physics a little bit and how calculus relates to physics. So quickly, refresher from Calc 1. The main objects that we're thinking about is for a particular object traveling through space, we want to know the relationship between its position, its velocity, and its acceleration. Usually the position function is denoted as x of t. So our variable is time because as an object moves, it moves as time progresses. So x represents its position as a function of time. Velocity, v of t, is given by taking the derivative of position over time. So we take the derivative for position, we get velocity. So v of t is the same thing as x prime of t. Often in physics, it's going to be denoted by x with a dot on it. So I'll just write it here just in case you see it. X dot is the velocity. And then the third idea is the change in velocity over time is acceleration. So this is denoted by a of t. It's going to be the derivative of the velocity over time. This is how much your velocity is changing instantaneously. So acceleration, the more you accelerate, the quicker your velocity goes up. And the notation for this is going to be x double dot, the second derivative of x. That's how the physicist would describe it. So between these three ideas, we'd like to know, with our newfound understanding of antiderivatives as areas under the curve, and can we interpret what it means to take a definite integral for, say, velocity? So if we're starting at velocity, an antiderivative will give us position. But because we're looking at signed area, the signed area below the velocity is going to tell us about how much we've possibly changed in our position. So what that is called total displacement. So total displacement is going to be given by the integral from a to b of the velocity function as time changes from a to b. So this will tell us overall how much our object has moved over that time gap from a to b. Similarly, if you'd like to know what the total change in velocity is, you just need to do the definite integral of the acceleration function over time. So these are going to be the things that you use to answer questions in the homework, in the word problems. So if you have questions about those, go ahead and post those into the discussion boards. We'll talk about them. We'll try to solve them together. We'll help each other, and we'll have a great time. So enjoy doing the work this week, and I'll see you in a bit.